sampling. Methods of sampling means random sampling technique and non-random sampling technique. Two types of technique. When you use your research as well, you want to explain in methodology chapter what type of sampling technique you apply. Random sampling technique or non-random sampling technique. What is meant by random sampling technique and non-random sampling technique? Random sampling technique, probability is included. Probability. Therefore, we say random sampling technique. Sampling technique consists of probability. That's why random. Non-random sampling technique, probability is not included. Better if you can use random sampling techniques in normal studies. But some studies there, you cannot apply random sampling technique. You have to go for non-random sampling techniques. Right. Now methods of sampling you can write down like this. Sampling techniques can be classified. Sampling techniques can be classified as random sampling techniques and non-random sampling techniques. Random sampling techniques consist of probability. Non-random sampling techniques does not have, or non-random sampling technique does not have probability. In general studies, better to use random sampling techniques. There are some studies where we cannot apply random sampling technique. But you can see these are the random sampling techniques. Simple random sampling or lottery method, stratified, systematic, cluster, multi-stages, different types of sampling techniques. These are called random sampling technique. Probability is included. One by one, we want to discuss. Right now, we take first one, simple random sampling. Or lottery method. Right, simple random sampling means this method Simple random. Equal opportunity is there for all the items of the population items to be selected into sample. Equal opportunity is there. As an example, in your organization, there are 1,000 employees. All the 1,000 employee numbers you can put into a box, mix up, and 100 you select. Equal chance is there. 100 when you select, what is the probability out of 1,000? 100. 100 over 1,000 is the probability. Equal chance. Lottery winners are selected based on that. If you buy a lottery, equal chance is there to be the winner. 20 million lotteries are printed, you will be one of 20 millions. If you buy 2 lotteries, 2 of 20 millions. That is the probability. Right, that's why simple random sampling, equal chance is there. That is the definition for simple random sampling. Right, now we write down giving equal opportunity, giving equal opportunity, giving equal opportunity to all the items of the population, to all the items of the population. To be selected into sample, to be selected into sample, if we select our sample, if we select our sample, that is called simple random sampling. Simple random sampling. Lottery winners are selected. Lottery winners are selected based on this method. Based on this method. Therefore, this is called lottery method. Therefore, this is called lottery method. Right, with the example, we write example, one example. Example. If we have 1,000 employees, we have 1,000 employees. We can put their employee numbers. We can put their employee numbers into a box. Into a box. After that, numbers can be mixed up and 100 can be selected. And 100 can be selected. Right, that's why lottery winners also, all the numbers included, ping pong balls, randomly, they are simple random sampling. Now, what are the advantages of simple random sampling? Advantage. First one is simple method, right? First one, simple method. Advantage, simple method. Second one, equal chance is there equal chance is there to be selected into sample. To be selected into sample. Right, there are disadvantages of showing simple random sample. Disadvantage. Right. Not always. Sometimes there may be biased data. Sometimes. When you select 100 employees, randomly you selected, but unfortunately, all the selected employees may be male employees. Randomly happen, but bias. Female is not represented. Right. That problem, there may be some time. Right. Now, first one, sometime there may be biased data. Sometimes there may be biased data. Example, all the selected employees may be male. All the selected employees may be male. Next disadvantage, when you select that random sampling technique, we need to consider sample frame. Sample frame means entire population should be represented by a document, right? Employee register, from where you can take employee numbers, right? Or maybe telephone directory. Then you can find the people who are using the telephones. Or maybe students register, students list. Like that, you want to take a document which represent all the items of the population. Otherwise, you can't apply simple random sampling. Therefore, to apply simple random sampling, you have to work hard. That is the disadvantage. You need to make some sort of attempts. You need to find. If you lose any number of the employee, then your sample frame is not there. Okay, right. Therefore, we write disadvantage. We have to make more attempts. We have to make more attempts. To satisfy the sample frame. To satisfy the sample frame. To satisfy the sample frame. Sample frame. Near the round sample frame. Right, within bracket, write down. Sample frame means that entire population should be represented. Entire population should be represented by a document. By a document. That is called sample frame. That is called sample frame. Right. Example, employee register. Employee register. Right. That's why sometimes you may be saying in your dissertations, I apply random sampling techniques, but your population will be the customers. If you select customers, what is the sample frame? All the customer numbers or names you should have. Otherwise, you can't apply random sampling technique. Then you can go for convenience sampling or those type of sampling. Right? To apply simple random sampling, sample frame is required. There should be a document which represents all the items of the population. Right? That is the simple random sampling. You produce all the items, right? All the items, you put the numbers 1 to 10,000. 1 to 10,000 numbers you can put into a box. Then randomly select 1,000. Simple random. But the population there should be to apply random sampling technique, simple random sampling. Okay. Right, then we can go for stratified sampling. Stratified sampling. Stratified. Staraniyati. Stratified. Simple random sampling. Sarala sasamba niyadi. Stratified is Taraniyadi. Stratified. What is meant by stratified? The disadvantage of simple random sampling technique can be minimized. We identify the strata or stratification of population. Example, your employees may be classified as male, female. Or according to educational level, low level employees, A level qualification, graduate qualification. Likewise, stratification you can identify strata. Strata. Right. After identifying that strata, is in the right. We identify that strata. Then you calculate ratio of stratification. Ratio of stratification you need to calculate. Ratio. According to that ratio, you select sample items from each stratification. That is called stratified sampling. Example I explain like this. Now suppose that you are having employees, simple example, 50 employees. Male you have 30, female 20. Right? Then you calculate ratio of stratification. This is the ratio 30 to 20. Otherwise 0, 0 you can set off 3 to 2. That's the ratio. If you take the total 5. Then suppose that you need the sample 10 employees. 10 employees you want to select. Then how you do that? Then 10 divided by 5 multiplied by 3, then 6 male employees you select. Out of this 30, randomly you select 6. 10 divided by 5 multiplied by 2, then 4 female you select out of this 20. Then all this stratification will be represented. That's why it is called stratified sampling. All strata will be represented. Like that, education also you can consider. O level, A level, graduate, how much employees, then maybe 3 to 2 to 1, maybe. Then accordingly you want to select your sample. Right, now we write down. According to this method, we identify a stratification of population. stratification of population. Stratification of population, and then ratio of stratification is calculated. Ratio of stratification is calculated. According to that ratio, sample items are selected. From each stratification. Sample items are selected from each stratification. As an example, employees can be classified as male and female. After deciding the ratio, we select employees from both male and female. Try one example right now. This example we take. Suppose that we have 50 employees. Such as 30 male, 20 female. Right, under that write down ratio of stratification. The 30 to 20. Then simplify 3 to 2. 3 to 2. Male 30, female 20, then 30 to 20 means 3 to 2. If you want, you can take total. 3 plus 2, 5. Ratio total 5. Right, under that write down, we need the sample size of 10 employees. We need the sample size of 10 employees. Right, now then we need 10 employees. Right, then to do the calculation, our sample. Right, 10 over 5 multiplied by 3, 6 male. 10 divided by 5 multiplied by 2, 4 female employees. Right, like that you can select from each strata. Right, in our studies we do. We select. First year, second year, third year, fourth year, we select like that. Right? Or in area wise you can select. Employees, education wise you can select. And therefore you can decide which strata you need. What are the advantages of this? Right. Main advantage is all strata will be represented. Right. First one, all stratification will be represented. All stratification will be represented. Right. Accordingly, we can see the second advantage. We can minimize biased data. Second disadvantage. We can minimize biased data. We can minimize biased data because all will be represented. Therefore, we can do good analysis. Again, disadvantage is there. No machine data. Therefore, sample frame should be considered. You have to pay attention. Right. First one, we need to pay attention for sample frame. We need to pay attention for sample frame. Because 30 male employees should be there, 20 female employees should be there. Otherwise, you can't satisfy sample frame. All the numbers there. Right. Then, second disadvantage, if you cannot see any difference in stratification, all are male, you can't apply. All are graduate, you can't apply. Then you can go simple random sampling. And second one, if we cannot see a difference, in stratification, this method cannot be applied. This method cannot be applied. Example, all are male employees. Male. Then you can't use. Then we need to come to systematic sampling, third one. Systematic sampling. Ramavat niyati. Systematic. And systematic sampling means it indicates system. Entire population you divide into number of parts according to the size of the sample you need. Suppose that equal parts we divide entire population. If you want to divide, you want to select 10 items. Suppose that 10 employees. Then all the employees you divide into 10 parts. If you want to select 20 employees, all the employees you divide into 20 parts. After that, from this part 1, we select 1 items randomly, simple random sampling method you apply to the first part. From that, you select 1 item. What is the number of that item? Same item you select from other parts also. That's why it is called systematic. After selecting the first one, it is easy to decide others. Okay, from an example, I explain further. Right. First, we write down like this. In this method, we divide our entire population. Into number of parts. According to the size of our sample. After that, one item is selected One item is selected from part one, by using simple random sampling method. Simple random sampling method. Then same number from other parts. Same number from other parts is also selected. From example, we understand better. Right? Example, write down one example. Suppose that there are 100 employees. Suppose that there are 100 employees. 100 employees. Suppose that there are 100 employees. We need a sample size of 10 employees. We need a sample size of 10 employees. Right, we need 10 employees. Therefore, your entire population 100 you divide into 10 parts. If you want to select 20 employees, 100 should be divided into 20 parts. Now here 10, therefore you divide your employees into 10 parts. Part 1, part 2, part 3, like that we divide all these. Then I can take last one, part 10. Now suppose your employee numbers from 1 to 100 you are having, then you assign 1 to 10 employees here. 11 to 20 employees part 2. 21 to 30. Last one, 91 to 100. Then 31 to 40, 41 to 50, like that you can assign parts. Right, 20 employees, if you want to select 1 to 5, 6 to 10, like that, you can assign. Now, from part 1, right, here, randomly you select, suppose that we select randomly 5th employee from part 1. Right, randomly these 1 to 10 numbers you put into a box, mix up, randomly you select 1, then number 5. If it is same number, 5th you select from other parts also. That is 15, 25, 35, 45, 55, last one 95. That is systematic. Right, then write down under that. Suppose that when we select one employee from part 1, the number is 5. Right, in here number 5. If it is you select same number, then our sample 15, 25, 35, 45, 55, likewise, last one 95. These are the samples. Sample items, numbers of employees 5, 15, 25, 35, so on. If you select from part 1 number 4, from other parts also 4, 40, 24, 34, so on. Another example you can do like this. In the production line, you want to test the quality of a product. Then you select every 10 items you produce, you take number 5 to test the quality. Right? Likewise, you can decide. Another example to write down. Example 2 for systematic sampling. We can select fifth item, right? Any item, right? Fifth item to test the quality. When we produce 10 items, in the production line, every 10 items when you produce, one item you select, same item you select. That's why it's disconnected. What is the advantage of this? Advantage is, after selecting the first one, it is easy to decide the others. Right. First advantage, after selecting the first one, it is easy to decide other items. Again, smaller parts you divide. Therefore, sample items can be expanded throughout the population. Part by part you select. Then we write down second advantage. Sample items can be selected. From each part. Therefore, they can be distributed throughout the population. And because in the production line, all the bulk you are not selecting to test the quality, select, right? Every 10 items, one. So then entire production, you can expand your sample items. What is the disadvantage of that? Unfortunately, if first item is biased, sometimes other items may be biased. Not always, sometimes. But employees, it will not be biased. But the production line, sometimes there may be a bias. Because of a machine problem, when you produce 10 items, machine will problem. Then fifth item is defective. Then that is systematic, right? Always fifth item will be defective. Right? In production line, it may be happening. Sometime, right? Disadvantage we write down. Sometimes there may be biased data. Example write down, then you can understand better. Example. Because of the machine problem, if the fifth item is defective, all the items of the sample will be defective. Right. Then another one, when you select that 100 employees from that, you have to understand your sample frame, right? Then second, need to pay attention for sample frame. Need to pay attention for sample frame. Right, all the items, there should be all the employee numbers, there should. Right, what is multi-stage sample? Multi-stage sample. Bahu piyavarani multi-stage sampling. Multi-stage sampling is very much appropriate in large area studies. If you are conducting your studies, what we do here, we follow several stages before selecting the sample. Several stages you want to follow one by one. First stage, second stage, third, fourth, likewise. Number of stages will depend on your study, but several stages we follow. Sample items should be selected from the final stage. That's why it is called multi-stage sampling. Multi-stage. As an example, you want to select sales representatives. Sales rep you want to select to your organization. Then you decide first stage, what are the provinces I need sales representatives? Some area, some provinces you select. Then in selected provinces, the second stage, what are the districts I want to select from selected provinces? Then you have to decide what are the divisions I want to select from selected districts. Likewise, we are filtering. Then final stage, you want to go to the correct place, or you want to call interviews from particular areas, then select your sales representatives. That is multi-stage sampling. Scholarships, when we provide scholarships, and also when we start some projects to develop the poor people, we decide what are the provinces. In these provinces, what are the districts? In these districts, what are the divisional secretariats? In these divisional secretariats, what are the areas? Then what are the villages? Likewise, we are filtering stage by stage. Okay, right. Now we write down multi-stage sampling. As we follow several stages, before selecting the sample, this is called multi-stage sampling. This is called multi-stage sampling. Sample items are selected. From the final stage. As an example, if we need to select, poor people, we need to select poor people to start a project. Following stages can be applied. To select the sample. Right, in stage one, decide provinces. What are the provinces you want to start this project? On a palatha, we have decided. Suppose that 2-3 divisions or provinces you select. Then in stage 2, decide districts. decide districts of selected provinces. Some example I give. If you want one more stages, you can follow. Stage 3, decide divisions of selected districts. Then stage 4, decide village of selected divisions. Right? Village or some areas you can decide. So then finally you want to select. Stage 5 and then select the sample. The poor people you select. Sample is poor people. Like that, some stages you can decide. No need to follow all the 5 stages, but it depends on the start. Right. Now, when you provide scholarships to students, you can decide like that. Scholarships. You can introduce multi-skill sample. What are the advantages of this? First advantage is better in large area studies. Right? First one, better to apply in large area studies. Better to apply in large area studies. Better to apply in large area studies, island-wide, worldwide, when you decide, you can do it. Then second advantage, from the final stage, you select your sample. All these you can decide, right? By using details, you can decide. In the final stage, you have to go to the particular area only to the selected where? Select the sample, selected village. You want to go there. You have to visit there. Or sales representatives, you want to select from selected areas. So then you can minimize cost because final stage we select our sample. Therefore, you don't want to visit all the provinces, all the districts. You don't want to visit. You don't want to call interviews from all. If it is, it will be a high cost. Finally, you want to call the people for interviews from selected village or selected divisions like that. Therefore, cost can be minimized. Second advantage, as we select our sample, from the final stage, cost can be minimized. Right? No need to visit all the different provinces, all the districts. No need to call. Selected parts you have to go. What is the disadvantage? Disadvantage is, right? If you are one of the selected area is biased, previous stages is biased, definitely final sample will be biased. That's the problem. Okay, so disadvantage. If one of the previous stages is biased, if one of previous stages is biased, our sample will be biased. Our sample will be biased. Right? Sales representatives you want to select. Right? But unfortunately, by a mistake, you have selected wrong province. Then to the particular province, districts are also selected from the particular province. Then divisions, division secretaries, all this will be biased. Okay. And suppose that poor people you want to select. Then you want to pay attention for the people, poor people, those who are living in the particular areas, right? Poor people. Then as a area, you select Colombo Cinnamon Garden at the beginning. Then you analyze data. Then the living standard of the poor people in Sri Lanka is very, very poor. They are using only 2 vehicles. In the analysis, it comes, no? Right. Sample will be biased. Therefore, correctly selected. Next is cluster sampling. Cluster. Pokuru cluster. And this is also appropriate in large area studies, cluster sampling, which select some areas which are relevant to our study. Right? This area, this area, this area. Likewise, some areas we want to select. Suppose that A area, B area, C area. Then all the items of the selected areas you include into your sample. Then this is my sample. Initially, you want to decide the areas which are relevant to your study. Then all the items of the selected areas are included into the sample. That's why it is called cluster. All the items are selected. That's why cluster. Now only you have to decide what are the areas which are relevant to your study. Then all the items will include into your sample. That's why it is called cluster. Clear? Right. As an example, you want to study the poor people. Identify the area where there are poor people. And rich people also may be, but majority poor people. Then those areas you identify and include into the sample. We did cluster sampling, COVID-19 cluster, Paliagoda cluster, Navy cluster, Brandix cluster. Like that, we selected the areas where the COVID-19 influence. Then those areas we included into sample. When you decide at the particular time, no need to worry the sample frame. If the person belongs to Paliagoda, then that person also belonging to our sample. No need to worry about sample frame. If the particular person is Navy, yes, you also belong to the COVID-19 cluster. We face that problem. That is cluster sample. Right. Now we write down. In this method, we have to identify the areas. We have to identify the areas which belong to our sample. All the items of the selected areas, are included into the sample. As we select all the items, of the selected areas into the sample. This is called cluster. This is called cluster. පොකුරක් කියලා කියන්නේ ඒකයි. This is called cluster. Right, example we write down. Example. If we need to study the effect of COVID-19. Same example we take. Effect of COVID-19. Initially, we have to determine the areas where COVID-19 has influence. Then select all the people of selected areas into the sample. Right, in bracket, if you want, you can write A, write variable cluster. B, navy cluster. C, other one you can take, right? This is Brandix cluster. Like that, you can see COVID-19 influence those clusters. All are selected. The poor people, if you want to start, initially identify the remote areas where the poor people are living. Then all people of the selected areas will be included into the sample. Initially, you study, according to this study, you want to decide the relevant areas. That is sample. And what is the advantage of this? Again, better to use in large area studies. Then next one, all the items of selected areas are included into the sample. Therefore, you don't want to pay attention for the sample grade. The Navy cluster, when you select, you don't want to identify the employee numbers of Navy. Because if you belong to Navy, yes, you belong to the Navy, that COVID-19 cluster, like that, right? Second advantage, as we select all the items, no need to consider sample grade. No need to consider sample grade. Right, here also disadvantage is there. The disadvantage is if your selected area is biased, your analysis will be biased, sample will be biased. You want to test the COVID-19 effect, but you have selected an area no any effect, then the analysis will be wrong. Right, that's why. Again, the poor people you study, then selected highly rich area, then your analysis will be wrong. Right, then disadvantage, right? If one of our selected area is biased, sample will be biased. Because area C, no any COVID, any effect. then your sample will be biased. Right, these are the random sampling techniques. We want to move to non-random sampling techniques. Non-random. 10 we take non-random. 10:30 you take a break. 10:30, right? Non-random sampling techniques. Right, as the probability is not included, we say that non-random sampling techniques. Right, first one, easy sampling, no convenient sampling. Easy sampling or convenient sampling. Pahasu niyadi, pahasu. Easy sampling. Easy sampling, from that you can recognize this sampling. Easy. From where we select our sample items, easy. Very quickly and easily if you can select, that is simple, that is convenient sampling. As an example, when you do the production, very close items you select to test the quality. Convenience. You are going to study the customers, you go to supermarket, being in the entrance, the customers, those who are coming first, you select for the sample. Distribute the questionnaire or make interviews to collect data. That is convenience. Convenience. From where you can select your sample very easily, that is convenience. Right. Now we write down very easy. If we can select our sample items, if we can select our sample items easily, that is called convenient sampling. That is called convenient sampling. As an example, very close items can be selected. Very close items can be selected to test the quality. To test the quality. Example 2. The customers who are coming first. The customers who are coming first. The customers who are coming first can be selected into the sample. Can be selected into the sample. Right, that is convenience. What is the advantage? Advantage, very easy method. Very easy method. Convenience. Second one, studies can be completed quickly. Studies can be completed quickly. Yes, disadvantage is, right? Disadvantage, sometimes there may be biased data. Very close items, maybe high quality items, purposefully producer has stored there. Very high quality. More and more defective items there. They are disadvantage. Sometimes there may be biased data. Sometimes there may be biased data. Because in the supermarket, when you collect data, when you select customers, in the particular day, there may be extraordinary customers. Right? A particular event there may be organized. Because of that, extraordinary customers have visited there. Unfortunately, you have selected them. Maybe sometime, not always. Okay, there may be biased data. Purposefully, producers may be doing that. And when we are testing the quality, tea quality in tea factories, when the farmers are bringing these tea leaves, right? They are bringing by. That's the bags. So then the high quality leaves may be in the top. Then bad leaves may be inside the bag. Therefore, how they test the quality? They take in leaves from the bottom. Normally they do in tea factories. A test when they are testing the quality of leaves, tea leaves. But likewise, disadvantage, there are many. Right, next is quota sampling. Quota. Quotas nearly. Quotas. Quota. Right, in quota sampling also appropriately large area studies. What we do, we appoint several people, several researchers, right? Several researchers are appointed, several people. Each person is given a quota. Quota. Quota is there. Each person is given quota. Quota consists of description, specification, and what is your area you have to visit, what is your sample size, what are the stratification, what is the period of time, all these will be included into the sample. But according to that quota, each person should visit to the particular area, select sample and collect data. That's why it is called quota sampling. Quota. Right here, maybe right. This area, this area, this area, and this area. 4 areas you want to start. Several persons are appointed. Here one person, another one, A person, B person, C person, D person. Each person will be provided a quota. According to that quota, each person should collect data. That is quota sampling. In worldwide, in island-wide studies, it is better. You can use. Right, now we write down like this. In this method, we appoint several persons. We appoint several persons to select sample and collect data. To select sample and collect data. Each person is given a quota. Each person is given a quota. Quota comprises area of the study, size of the sample, stratification, period of time, etc. According to that quota, each person has to visit the particular area and select the sample. Like example, write down. Example. If we need to do a study about uncle businesses. Following quota can be determined. What is the area you want to do? Then you say, right, you have to visit, yeah. What is the size of the sample? Right, you want to select 100 sample. What are the stratification? Then you say, right, manufacturing unit, manufacturing, and maybe trading, then agriculture. Likewise, 3. Like 100 will be distributed 50 here, here 30, here 20. Likewise, stratification. What is the time period you give within 3 months? 3 months you want to complete this. Likewise, stratification will be provided, right? Each person, not the same. Another area, gold, it may be 150. Likewise, quota will be different. According to the particular quota, each person should do that. The researcher has to select sample and collect data. What is the advantage? Advantage, appropriate in large area studies. Appropriate in large area studies. Identified studies, appropriate in large area studies. Second advantage, as we appoint several persons, studies can be quickly completed. Right. Second advantage, as we appoint several persons, studies can be completed quickly. Studies can be completed quickly. What is the disadvantage? Studies can be completed quickly. A disadvantage, cost will be high. Cost, you have to pay more. Several persons, you have to pay. Second one, very difficult to satisfy the quota. Very difficult to satisfy the quota. Because you want to fulfill that quota, but difficult, right? Because we face that type of problem. German company Safi, they did the island-wide training program for SME sector, small and medium-sized enterprises. They train. They want to test. They decided starting the business, expanding the business. Therefore, after 3 years, they want to test the success of that training program. Then to decide that, it was given to our University of Colombo, Faculty of Management Finance, to do island-wide study, including Jaffna as well, to do this study and provide a report. So then, very difficult to satisfy this quota because I was assigned to Runagala, Aulegam, Nicavalatiya, Mahawar, then Abampola, Aulegam, Magula, right? Those areas. So then very difficult to satisfy those training programs quota. Why? Sometimes we want to travel after taking one, 40-50 kilometers we want to travel to identify another. Was long distance. Very difficult to satisfy. But anyhow, we did. The training program was successful. Within that time frame, we cannot achieve that. Therefore, extra period we have to take. And that's why I mentioned disadvantage, very difficult to satisfy the quota. But anyhow, you need to do that. There is a quota appropriate in the RBS. Second, next one is judgment sample. Judgment. Finished here. Judgment. Sometimes we say purposive. Purposive, same thing, right? Purposive. Purposive sampling or judgment. විනිශ්චය නියදීම, otherwise purposive, සහේතුක නියදීම, සහේතුක, purposive. Judgment means this is appropriate if you are unable to identify the sample items, right? If you do not have direct access to identify the sample items, you can take the support of another person. That person is having knowledge as well as experience with sample items. Then with that support, you can identify sample items. Suppose that you are working in a organization, right? Otherwise, you are doing research in research institute. Then there is a problem. Some employees are not working in organization, one organization. Then that is study was given to you. Then do you have access of become? No. Therefore, what we do, you take the support of another employee who is working there, or maybe manager who is working there. And with that support, relevant employees who are not working, you can identify. If you are working in the particular organization, no need that purpose. You know. Otherwise, if we are unable to identify sample items, you can take the support of another person who is having that experience and knowledge. We do like that. Then that is judgment. The judgment is given by the particular person who is having knowledge and experience. Then you have having access and also the relevant sample items you can select. Otherwise, it is difficult. That is judgment. Right. Now we write down like this. If we are unable to identify, we are unable to identify sample items correctly. Sample items correctly. We can take the support of another person who is having experience and knowledge. About the sample items. After that, correct sample items can be identified. Right, always identify with example, right? Example. If some employees are unsatisfied in an organization, we cannot identify them correctly as an outside person. We can take the support. Of a manager or employee working in that organization. With their judgment, unsatisfied employees can be identified. Unsatisfied employees can be identified. Right? Manager is saying this person is unsatisfied, right? Make interviews so you can take discussions and identify. That's all. What is the advantage of this? Right. If it is difficult to identify, sample items, if it is difficult to identify sample items, this method can be used. Second advantage, we can take the support of another person. Who is having experience and knowledge. About the sample items. Right. Therefore, we can get the access. Within bracket, we can get access. Right. Because manager is introducing you. Then you are having access. Right. Facilities will be provided. We do these studies. We did that type of studies to identify the charismatic leadership of managers, right, in government industry. So then 2 days we did, the manager supported us. So then when we are going there, many supports will be given by others as well. Therefore, access is there. That is to identify the leadership styles, charismatic leadership. What is the disadvantage of this? Right, only disadvantage is sometimes there may be personally biased data. Because sometimes there may be personally biased data. Employees may be biased to manager. Being biased, they may provide information. That type of problem will occur, right? Sometimes. Right, the last one, snowball sampling. After that, we take the break. Or now you want break. After this, no? Right. Snowball sampling. Snowball near the snowball. This is also something related to judgment sampling. What we do, if it is difficult to identify the sample items, what we do, we expand our relationship. Expand in relationship one to one or one to many, you can identify sample items. We expand our relations. Here only a person is giving the access, the direction will be given. But here we expand our relationship from one to one. Very difficult items. If you want to study about Sri Lankan history, then very difficult to distribute a questionnaire and collect data. So anyhow, you want to identify a particular person who is aware of that history. Then from that person, you can pass to one or many, like that. Isn't it? That is snowball sampling. Irrigation system, ancient time irrigation system you want to study. Then anyhow, one person should be identified. From that person, you can expand that relationship further and further to identify other people. Those people are having knowledge. They know the other people. Sometimes we do in illegal activities. These studies. Drug abusers. One person you want to identify anyhow. From that person, one or many you can identify. You can pass, isn't it? Murderers. One to one or one to many you can expand. And sex workers, prostitutes, where you want to do a study about the prostitutes of Sri Lanka. Then anyhow you want to identify one person. After that you pass that message one to one like that. Better to apply those type of studies. Clear? Now we write down snowballs up. If it is difficult to identify sample items, we expand our relationship. We expand our relationship to identify the sample items. To identify the sample items. After identifying one items, relationship can be expanded. Relationship can be expanded further. Through that item. Through that item. If we expand that relationship, from one to one, one person to one, right? One to one. That is called linear snowball. Linear snowball. That is called linear snowball. If we expand that relationship, from one to many, like that. One person, many persons can be identified this way. One to many. That is called exponential snowball. Exponential snowball. Exponential snowball. Rekiya, Gatiya. Rekiya snowball, Gatiya snowball. Example, write down. Example. If we need to study ancient time irrigation system. Ancient time irrigation system. Ancient time irrigation system. We should identify one person. Using our relationship. We should identify one person using our relationship. Then more people can be identified. Through that person. Right? One murder, if you identify through that person, more murders you can identify. Like that. But what is the advantage? Advantage is, right, if it is difficult, we can use this one. Right? That is the advantage. If it is difficult to identify sample items, this method can be applied. Second advantage, in the studies of illegal activities. In the studies of illegal activities. This method should be applied. This method should be applied. නීත්‍යානුකූල නොවන ක්‍රියාකාරකම් පිළිබඳ studies වල this method should be applied. Example, murderers, drug abusers, sex workers, like that. Right? You know that this method should be used. Otherwise, you want to study the prostitutes, then you prepare the question. After preparing the questionnaire, go to a supermarket. When a lady comes, you ask, are you a prostitute? If it is pink, can you see? Research cannot be start like that. You can start, but you can't finish. Because there may be a problem for your spinal cord. Right, therefore, you need to select correct sampling method. What is the disadvantage? Again, disadvantage is sometimes there may be personally biased data. Sometimes there may be personally biased data. Right, that is sampling methods we discuss. That is the end of our introduction part. Introduction to statistics speech. That is the first function, collection of data it is finished. Functions we use. Right, collection of data, that part is finished. Collection. Then we want to start after the breaking organized of data. Now take a break, then we start organizing of data. Data organizing. I send another handout to collectors. No? Okay. Right, data organizing. That is our main topic, data organizing. Right. When you collect data, before they are arranged, they are called raw data. Raw data. Raw data. Raw data should be transformed into organized data. We have to arrange in order, ascend in order, descend in order, like that we do. Then they are called organized data. Organized data. That for transforming raw data into organized data is called data organizing. I think that you have done all this, therefore we can expedite data organizing, but you need to revise your knowledge, previous knowledge, right, before starting the calculations. Right now we write down like this. When we collect data, when we collect data, they are called raw data. They are called raw data. When we transform raw data, into organized data, organized data. That is called data organized. That is called data organized. This means that transforming raw data into organized data is all data organized. Following methods can be used to organize data. First one, array. We have done this, but briefly I discussed array. Second one, array. Second one, frequency distribution. First one, array. Second one, frequency distributions. Frequency distribution consists of first one, ungrouped frequency distribution. Ungrouped frequency distribution. Second, grouped frequency distribution. Group frequency distribution. Third one, cumulative frequency distribution. Cumulative frequency distribution. Cumulative frequency distribution. So we want to organize this. That when you are organizing, you will identify some technical terms, class, width, real limits, practical limits. Then you want to take upper limit, lower limit, practical limits, mathematical limits, different terms you need to understand. Without them, you can't start calculation part. That's why. Or the organized data presentation part also you can't do. Right, first we take array. Array means when you organize your data set in ascending order or descending order, that is called array. Very simple. Ascending order or descending order. When you use, very quickly you can identify minimum value, maximum value, range can be calculated, and also many times repeated observation can be identified very quickly. These are the usage of array. Okay, right, we write down like this. When we arrange a data set, in ascending or descending order, that is called array. Usage of array can be given below. First one, can identify minimum and maximum value quickly. minimum and maximum value quickly. Second, range can be calculated. Range can be calculated. Third one, repeated observations can be identified. Repeated observations can be identified quickly. Right, example we can use, right? Question number 2 we can do, right? Now write ascending order, descending order, right? Ascending order, right? You are aware of this. Right, question number 2, ascending order, write them. So then you can identify array. That is array. This is question number 2, 10. Therefore, I write my array. I want to write array. Minimum value 10, then 12. Next one 14, then 15, then 17. Like that you can continue. 18, 20, 24, 26, 28, 32, 35, 36, 39, 42, 39 and 42. Right, you can calculate this, no problem. But when you are having more data, right? I did not calculate in the board because the other people cannot see. That's why next week we can do all these calculations in the board. Right, now when you are having more data, it is very difficult to do like this. Therefore, we are using another method for arranging data in ascending order, descending order. You have done stem and leaf diagram. Have done stem and leaf diagram. Attapattu, you have done. I know that you have done. Right, stem and leaf diagram. Right. Under that, write down. When we have more data, we can use stem and leaf diagram. We can use stem and leaf diagram. Stem and leaf diagram. To organize an array. To organize an array. Right, now stem and leaf diagram, what we do? Last digit you write in leaf part, stem part, primary digits you write. So then row wise you can handle your values. Then here and there you can put numbers, then continuously you can write ascending order or descending order. Because limited numbers you have to arrange row wise. Then very easy. I briefly write down like this. There are two parts. In the stem and leaf diagram. as stem part and leaf part. Stem part and leaf part. Last digit we write in leaf part. Other digits are written in stem part. Then we can organize data row-wise. Then we can organize data row-wise. After that, array can be written. Right now you want to take like this. First stem part, but only you have to take limited spaces enough for stem part, then leaf part. Like that you can do that. Leaf part. Stem and leaf part. More space we need to take for the leaf part, stem part, only 1 or 2 digits we write. Therefore, stem part. Now take stem part. And leaf part. Stem and leaf. Now check your numbers. Number of employees of ABC Bank who are absent for 40 days has been provided as follows. 25 or 85 like that. Minimum value you can check 25. 22 there. Maximum 88 there. Yes, 88. 20 to 80 numbers should be covered. 2 digits means last digit we write in leaf part. Therefore, then 2 represents 20s because last digit we write in leaf part. Now I start from 2. 2 means in this row when you write 20s, then 3 30s, 40s, 50s, 60s, 70s, 80s. I need to organize up to 80s because 88 is the maximum. Then we write like this. 2 to 8. 2, 3, 4, 5, 6, 7, 8. So maximum 8. Now write your digits starting from first. 25 means in this row you have to write, but if there are more digits before that, we won't write, therefore keeping some space. Write 25. I write here 5. If more digits, I can write before that. Here and there, we won't write. Limited numbers we can handle row-wise. 0 to 9. Then easy. Write then 25. Next, 85. It belongs to this row, therefore 5 you write here, 85. No need to count the distance, right? 85. Then 40 means in this row, at the beginning also you can write 0 because no any value prior to 40. Then 65 in this row anywhere, 65. Then 35 in this row, write 35. Then 72 in this row, 72. Then 58 means this row. 58. 44. After 0, write 44. Anywhere. Then 64. In this row, before 5, write 64. Then 28. In this row, after 5, write 8. Right, likewise, I think that all you can cut. Clear? $25 in this row, 85, 40, 65 in this row, 35, 72, 58, 44, after 0 we write 44, 64, prior to this 5, 28, right, again continue 72, again 2, 88, 38, 30, 53, 53. Yeah. Right, 42, 59, 42, 59. Right, that your hand. 51, 53, 67, 49, 53, 72, 72, 56, 46, 56, 46. Like that you can see. Right, then 83 in that row. 35, 56, 64, 53, 63, 42, 78. Here and there we have to put the numbers. 85, 61, then 50, 49, 22, 38, 79. Right, then you can continuously write your digits, numbers. No problem. Right, then write your numbers. Right, then you can organize your array. Right now, write. Continuously you can write. Right, I start from this 2, 22, 25, 28. I column wise I write, or row wise you can write 30, 35, 30, 35, again 35, 38, again 38, like that, right? Right, then 40, 42, 40, 42, again 42, 44, 46, 49 two times, 49, 49, right, 50, 51, 53 four times, 56, 56, 58, 59, 61, 63, 64 two times, 65, 67, 67, 65, 67, 72. Right, again continue. I write that part here. I write here 72 three times. Right, 72. Again 72, 78, 79, 83, 85 two times. Last one 88. Right, then you can write your minimum value usage 22, maximum value 88, 88, this is 88. Right, then range can be calculated, range, maximum value 88, subtract minimum value 22, 66 is the range. Then you can use repeated observation, many times repeated observation you can check because continuously you can identify 28, 35, 38, two times, 40, 42, two times, 49, 42 times, 53, four times. Then you can see 53 is the many times, 53, three times 53, because four times, is two times, 64 two times, 72 three times. If it is highest repeated one is 53. You can identify like that. That is array. Stem and leaf diagram we take as the support. From that you can organize. Right, then we want to practice next one, frequency distribution. Right, now we take frequency distributions. Frequency distribution. Right, frequency distribution means the frequency observation with frequency may be provided, or may be class with frequency provided. Examples 3, 5 times, 9, 2 times, 6, 3 times. Like that it may be provided. That is observation. This may be 10 to 20, 5 times. 20 to 30, 4 times. 30 to 6, 30 to 40, maybe 7 times. Like that frequency may be provided. This is called ungrouped frequency. This is called group frequency. Ungrouped means just observation with frequency. Group means class range with frequency. Right? Therefore, you need to understand ungroup and group frequency distributions. Right. Now we write down. If we organize data with frequency, they are called frequency distributions. They are called frequency distributions. They are called frequency distributions. If the frequency is provided, to the observations, that is called ungrouped frequency distributions. That is called ungrouped frequency distributions. When we have more data, with repeated observations, ungrouped frequency distribution can be arranged. Ungrouped frequency distribution can be arranged. Right, more data there, majority repeated. So then ungrouped, no problem. Because when you take number 3, maybe 5 times. Then number 5 maybe 10 times. Like that, majority are repeated. Right, example, write down this one. I write here because others cannot see, that's why. Right, observations. Or otherwise you can use X and frequency F. Right, this example I write 3, right, 5 times. Next 9, 2 times. Then right, 6, 3 times. Like that you can say. This is ungrouped because just observation with frequency. Otherwise you can use 3, 6, 9, no problem. This is ungrouped. But group means class range we take 10 to 20, 20 to 30, like that we use. Then it is group frequency distribution. Many observations there, but majority are not repeated. Therefore, as the class range we take, right? Class range we take more observation to the class range, but majority are not repeated. Because it may be 10 to 20, 10 one times, 11 one times, 12 one times. Likewise, if you are having ungroup is not appropriate because always you write frequency 1, 1, 1, 1, 1 like that. Therefore, better to organize data as group, class, range. Right now we write down. If we arrange a frequency distribution, with class range, that is called group frequency distribution. when we have more data, but majority are not repeated. Group frequency distribution can be arranged. Example, class and frequency 20 to 30, 30 to 40. You can decide class range, whatever the class range. 40 to 50. Like that, this is group. This may be 3 times, this is 5 times, this is 2 times, like that you can take. Right, this is group frequency distribution. How you interpret this? 20 or more less than 30, 30 or more less than 40, 40 or more less than 50. Sometimes this group frequency distribution, you can arrange like this. Instead of this, 20 and 29. Then adding 1, 30, 39. Adding 1, 40, 49. That is most appropriate. This type of distribution. 3, 6, 9, 10. Right. When you interpret 20 to 29, 30 to 39, 40 to 49. Here how you interpret 20 or more less than 30, 30 or more less than 40, 40 or more less than 50. Right? Right. Now when you organize these distributions, more data, then what is the mechanism you can use? You can use tally tables. Tally tables. Using tally tables, you can. Right. Then we write down using tally tables. Frequency distributions can be arranged. Right, now example we can practice here. Organize a group frequency distribution. Class width should be 10. Here, now for this data we practice. I start, right, for this data. Right, what is the minimum value? Here 20. 22. No? Right. Now let's start. I use the tally table. You can start from 22 itself or round figure to the next. Right, I start class 20, 29. Adding 1, 30, 39. 40, 49. 50, 59. 60, 69. 70, 79. 80, 89. Maximum 88. Is enough. Then take tally. After that, we take finally frequency F. F is the frequency. This is my tally table. Right, you have done this, but I want to revise that knowledge before starting the other calculations. Right, now you can take the tally table. Now start. Take class. Then take frequency here, tally. And the third column has frequency. To like that. Then start the class 2029. then 30, 39, like that too. 40, 49, 50, 59, 60, 69, 70, 79, 80, 89. I started from 20. Right, then we start 25, it belongs to first row, here one tally. 85, this row, one tally. Like that you have to use tally table. 40, here. 65, this one. 35, 72, 58, 44, 64, 28, 72, 88, 38, 30, 53, 42, 59, like that, cut it. 51, 53, that is 5 as a cluster, we take 5 observations together. 61, 67, 49, 53, again you start, 72, 56, 46, 5, 83, 35, 56, 64, 53, 63, 5 observations. 42, 78, 85, 61, 50, 5 observations. 49, 22, 38, 79. Right, then write your frequency here. How much? 2029, 3, here 5, here 7, here 10, right? 10, you are right. Here 6, here 4, here 5, here 4. It may be 40 observations here. 40. Right, this is your tally table. Now, without tally, if you delete this tally, then you can take with frequency and class range, it will become frequency distribution, group frequency distribution. Right, group frequency distribution, I take. Frequency here. This is my group frequency distribution 3, 5, 7, then here 10, 6, 5, 4. Right, this is my group frequency distribution. Okay. Right, now what is meant by cumulative frequency distribution? We are having here 857. Right. Now, cumulative frequency distribution means cumulative frequency. From class to class, you add the frequency, that is cumulative frequency distribution. Samuchita Sankhya Vyapti, right? Cumulative. Right. Now we take cumulative frequency distribution. Cumulative frequency distribution. Right. Now we write cumulative frequency distribution. Cumulative frequency distribution. CF, right? Cumulative frequency. If we add the frequency, from class to class, cumulative frequency can be calculated. Cumulative frequency can be calculated. That distribution is called cumulative frequency distribution. Cumulative frequency distribution. If we need percentage of cumulative frequency. Percentage of cumulative frequency can be calculated. Right now, I take class frequency, another column cumulative frequency. From class to class, you add first one 3. When you add this 5, it will become 8. When you add 8 plus 7, then 15. Next 10, 25. Next 6, 31. Next 5, 36. Then 4, 40. Cumulative frequency distributions. If you want to calculate percentage value of this percentage, right? You can take another column percentage. I write here another column this right side. Percentage of cumulative frequency you can calculate. Percentage. Another column you can take to the right side. Here this 3 out of 43, then to the 100 how much? 3 divided by 40 multiplied by 100. That value is the first row. That is 0, 0, 2, then 5. 15 is 7.5. Isn't it? 0, 0 set off, then 2, 5, 5, 15, then 2, 7.5%. First column 7.5%. Second 8 divided by 40 multiplied by 100. Right, then 8, 5 is 20%. Third one, cumulative frequency 15. 15 divided by 40 multiplied by 100. So then 75, then 75, 75, then 2 is 37.5. 37.5. Next 25, fourth row 25 over 40 multiplied by 100. Then 5 means 125, that is 2, 125. Therefore, this 67.5 is 125. Then 12 is 6, then 62.5, 62.5, 62.5. Next 31 over 40 multiplied by 100. In that column you are right. It is difficult for me to write because I use the mouse. Then 5, then 150, 155, 100 plus 2.5. 37.5. 37.5. Right, then 36 over 40 into 100. 100 means 590, that is 90, no? 90%. Then last one, 40 over 40 into 100, that is 100%. 100%. Right, like that you can do that calculation. That is the frequency distributions. From class to class you obtain 3, 8, 7, 50, 25, 31, 36 and 40. 10% of cumulative frequency. Right, now when you use this distribution, the important points you want to identify some names. Right, then we write down practical limits. Practical limits. Prayogika seema. Practical limits. Practical limits. What is meant by practical limits? The given limits. 2029, that is the practical limits. The given limits. If you use 20 or more less than 30, that is the practical limits, the given limits. But theoretical limits will be different. Right now we write down practical limits. The given limits are considered as practical limits. The given limits are considered as practical limits. Right, as an example, 2029. 2029. Right, 2029. This is upper practical limit. This is lower practical limits. Lower practical limits. Upper practical limits and lower practical limits. Right. Then you want to identify next one, real limits. Real limits. Real limits, otherwise theoretical limits. Real limits. Or theoretical limits. Theoretical limits. Real limits or theoretical limits. සැබෑ සීමා, තාත්වික සීමා, න්‍යායාත්මක සීමා, සෛද්ධාන්තික සීමා. ඔක්කොම එකයි. Right? That is real limits, theoretical limits. Theoretical limits means when you organize the data 20 or more less than 30, 30 or more less than 40, practical limits will be the real limits. If you have organized data 2029, 3039 like that, at 0.5 to the upper limit, subtract 0.5 from lower limit, then you can obtain 19.5, 29.5. They are the real limits. They are the real limits. In the calculation purpose, you want to use this one. The better method is 2029 adding 1, 30, 39, 40, 49. If you organize their data, that is most appropriate. Sometime we can see the data set organized 20, 30, 30, 40 like that. At that time, we consider the given practical limits as the theoretical limits. Otherwise, 0.5 you have to adjust. Okay, right. Now we write down. If we have organized data, as 2030, 2030, 30, 40, etc. Practical limits will be the real limits. Practical limits will be the real limits. If we have organized data as 2029, adding 1, 30, 39, etc. 0.5 should be adjusted. 0.5 should be adjusted to the practical limits. The practical limits to obtain real limits. To obtain real limits. Right. Example 2029. 2029. Right. Then at 0.5 like this. Right. 0.5 you have to adjust. At 0.5, subtract 0.5. From lower limit, subtract 0.5 to the upper limit at 0.5. Then you can see 19.5 and 29.5. Then the next class, upper real limit of this class will be the lower real limit of the next class. Right? This is called upper real limit. This is lower real limit. Lower real limit. Okay.
Always 0.5.
Yes, 0.5. Always 0.5.
We agree. We define limit. It's always 0.
Yes, always, because the class grade, and in one, if you have decided x1, always 0.5 you have to list 0.5. But just 20, 30, 30, 40, likewise, don't adjust 0.5. Practical limits will be the real. Right? Because 29.5 upper real limit of this class, when you subtract 0.5 lower real limit of this class, then both are so, right, then another term is there, mathematical limits. That is to identify only. Right, mathematical limits. Mathematical limits. Right, mathematical limits. Ganithamaya seema. Mathematical limits means sometimes data set, when you consider the data type, we cannot adjust 0.5 in the real world, but for the calculation purpose we use 0.5 you adjust. As an example, suppose that 2029, when you take this number of employees, then 19.5 employees, 29.5 employees. Practically, that in the real world we cannot see, even though for the calculation purpose we use that real limits. Therefore, it is called that is a mathematical limits. You need to understand to define only, but always we consider real limits in that situation. Okay, but number of kilogram, 19.5 kilogram, 29.5 kilogram, it's okay. Right. Now we write down mathematical limits. When we adjust 0.5, when we adjust 0.5 to obtain real limits, that value sometime maybe not in the practical world, even though it is, we consider real limits, in the calculation, then it is called mathematical limits. Example, understand. Example 2029, right? 2029, number of employees. Then 19.5, 29.5, we calculated real limits. They are mathematical limits. Because number of employees. Right, but suppose that like this, right? I take 2029 weight of a product, bar 19.5 kilogram, 29 kilogram. It is not the mathematical limits. They are there. Right, only to define you need to understand mathematical limits. Otherwise, always we consider real limits in the calculation. To interpret, identify. If anybody asks what is mathematical limits, you have to interpret. You have to say. For the type of data, even though we can't calculate, for the calculation purpose, we use real limits, then it is called mathematical limits. Right, then we need to understand next one, that is class width. Class width. Here you can see class width like this. Class width. Right. We take class width. Class width means difference between real limits is called class width. Consider 10 class width, but I use 2029. What is the class width? Difference between real limits 19.5, 29.5. That difference is the class width. Right? Because in the calculation, most important. When you calculate mean, median, mode, variance, standard deviation, distribution currencies, all these values, we consider these terms. Then you need to understand. Now we write down difference between real limits. Is called class width. Right, example 2029. The real limits 19.5, 29.5. Right, then write class width 10. 29.5 subtract 19.5 class width 10. Right, that. Just the values, if you have 20, 30, 30, 40, that difference. Real limits difference. Right, another term you need to understand, that is class mark. Right, then we take class mark. Class mark. Panki laku. Otherwise, it is called mid value. Mid value. Mid value. Class mark. Right. Every class you can see the center point value. Center point. That is considered as X value for the calculations. Right? Center point value. That is called mid value. Right. Now we write down center point value of a class. Center point value of a class is called class mark. Is called class mark. Center point value of a class is called class mark. Right, example 2029. You can take 20 plus 29 divided by 2. Right, 49 divided by 2 means 24.5. 24.5. Otherwise, you can do this one. Very easy method. 2029 take difference. That is math. Divide that difference by 2, 4.5. Then to lower limit you can add 4.5. 24.5. Or from upper limit you can subtract 4.5. 24.5. And if the class width is equal, very quickly you can calculate 4.5, 24.5, 34.5, 44.5, so on. If you take that difference. Right, that's the way we calculate class mark. As an example, 2029. Take the summation of both 20 plus 29 divided by 2. Answer is 24.5. Or take the gap of this 2029 gap 9. That value can be divided by 2, 4.5. Add to lower limit 20 plus 4.5. Then answer 24.5. Or from upper limit you can subtract 4.5. Same value 24.5. Right, only one term you need to understand after the data organizing. What is meant by open class? Open class. View the fund. Open class. Right, open class, view the fund, you can see endpoint of a class. 2029, 3039, 4049, end. Right, that is a class. 40 or above, you don't know endpoint. That is open class. Right, now we write. If we cannot see endpoint, of a class, that is called open class. That is called open class. Example 2029, 3039. They are close. I write 40 or above. 40 or above. This is open class. Open class. Open class. Okay, these are the things you need to understand in data organizing. Data organizing, real limits, mid value, open class, class width, these terms you need to understand. Then it will be very easy for the calculations. That is the end point. That is the second we have done. Introduction finish, collection of data. Then second, we finish organization of data. Third one, data presentation. Presentation I start next week. Okay, right. Now we can finish it.